In the medical field, X-ray scans have been used for decades to be able to see problems inside of the body. However, since X-rays are solely two-dimensional, obstructions inside of the body can potentially block vital information from being known. To counter this, medical professionals began using computed tomography scanners, or CT scanners for short. CT scans work by scanning the area of the body from multiple directions and then compiling those 2D images into a 3D image. Modern CT scans incorporate multiple different methods to take those 2D scans into a 3D rendering. However, there are two methods that are based in linear algebra, the least squares method and the Kazmar's method.
The least squares method is a form of regression analysis that finds the line of best fit for a set of data. Simply put, it often finds the least sum of squares of error by typically using a projection of B onto subspace or a space A in the general form of AX equals B. So sometimes when we have for example, if B is a vector and then A is a plane down here, sometimes vector B will not interact with plane A at all, and therefore there is no real solution. However, we can find a best approximation by typically just finding the projection of vector B onto space A, and that will give us a very usable and good approximation and that we can use for the image. So this is considered a good prediction because it counteracts a fair amount of error that comes into CT scans, because each pixel is its own matrix, and that can include error from measurement and obstructions and other sources.
Kazmar's method is an iterative algorithm for solving systems of linear equations. In computed tomography, it views individual pixel as a vector, whereas in the least squares method, it views each pixel as a matrix. The way that it solves them is that it takes a point on an initial vector and projects it orthogonally onto an intersecting vector. Once it has that point on the intersecting vector, it projects that orthogonally back onto the initial vector. This process is then repeated until it reaches a point of intersection between these two. And this entire process is repeated for every combination of intersecting vectors. And then the CT scanner itself takes all of those intersections and propagates a 3D rendering of the scanned area. Kazmar's method is generally regarded as more reliable than the least squares method because it produces a much clearer image of the entire area, whereas the least squares method produces a more simplified rendering of the scanned area.